Hello everyone, welcome back to our video class here at CSEC Math Tutor. In today's lesson, we are talking matrices and transformations. Matrices and transformations combined in the last question on your exam paper, your paper 2, and we have three important objectives to get through here. The first one is to determine the matrix of a transformation, to determine the matrix of a combined transformation, and to determine the matrix of an inverse transformation. Each of these are important concepts. And to be very fair, to make the most of this lesson, you need a good understanding of both matrices and of transformations. So if your foundation in matrices and transformations is a little weak right now, this lesson may not be the lesson for you. That doesn't mean that if you participate that you won't learn, but you may not benefit the best as you could possibly benefit if you had a good understanding of matrices and transformations. That's it. Let's go into it. So here we have a question that says, under a matrix transformation M, which is A, B, C, D, the points V and W are mapped onto V prime and W prime. So V is 3, 5, W is 7, 2, V prime is 5, negative 3, and W prime is 2, negative 7. Now, assuming that you're looking at this and you can't see what's going on, the way to proceed with this question is to set up a matrix equation. And what we normally do is that we take our matrix and we multiply our point and we get our image. So let's take that matrix A, B, C, D. A, B, C, D. And what we're going to do is multiply the point 3, 5. We're going to write it as 3, 5 as a column matrix and write the other point 7, 2. That gives us a 2 by 2 matrix. And once we multiply these 2 points, we're going to get these two. So we're going to write them in the same order, 5, negative 3, and 2, negative 7. So you multiply this matrix by your points and you get your images over here. Now, assuming that this was an equation 2a equal 10, the best way to solve it would be to divide both sides by 2. In this case, we would get a is equal to 10 over 2, which is 5. But we cannot just divide matrices like this. As a matter of fact, we don't divide matrices at all. What we have to do then is to multiply by the inverse of this matrix. And so that's exactly what we're going to do. We're going to, let's label them. Let's call this A, let's call this B, and call this C. And so in order to get our A, B, C, D, what we're going to do is multiply both sides of this matrix equation by B inverse. And not just multiply, but we're going to post-multiply. Now, pre-multiply means that we put the inverse in front, and post-multiply means that we put the inverse behind. And so what we're going to be doing is, once we've written the equation, we're going to post-multiply. Let me write that down. Post-multiply both sides by B inverse. That means, of course, that you'll have to go find B inverse. Now let's go to another page where we can do that workout and come back here to this one to talk about it. So here we have the matrix A, B, C, D. This is A, this is C, and this is B. Now we need to find the inverse of this. Remember how we find the inverse of a matrix. First, we find the determinant. So the determinant of B would be equal to 2 times 3. In this case, minus 5 times 7, which gives us 6 minus 35. And 6 minus 35 is negative 29. Now to find the inverse, now we take 1 over determinant, that's 1 over negative 29, multiplied by the matrix that we rearrange. We call that the adjoint matrix. So we're going to switch these two, 2, 3, and then change the signs of these two. So that becomes negative 7 and negative 5. And once we put this fraction in, then the inverse, B inverse, becomes negative 2 over 29, positive 7 over 29. Notice that there are negative and negative here. Positive 5 over 29, and negative 3 over 29. So what we're saying now is that we're going to take our ABCD. So ABCD is going to be equal to this matrix, 5, 2, negative 3, negative 7, multiplied by B inverse, which is this. Negative 2 over 29, 7 over 29, 5 over 29, and negative 3 over 29. Okay, now that we've set up our equation, let's multiply it out. May remember that we multiply row by column. So 5 2's 10, that's negative 10 here, over 29 here, plus row by column plus 10 over 29. The next one, let's just drag this down a bit. Row by column, 5 7's 35 over 29. And 2 times negative 3 here gives us negative 6 over 29. Let's go to the next row. Negative 3 times a negative 2 gives us a positive 6 over 29. And a negative 7 times a positive 5 gives us a negative 35 over 29. For the last one, row by column, negative 3 times 7 gives us a negative 21 over 29. And negative 7 times positive negative 3 here gives us a positive 21 over 29. Now, once you simplify this, you'll realize that this is equal to 10 minus 10 is 0, so that's 0. 35 minus 6, that's 29, and 29 over 29 is 1. 6 minus 35 here is negative 29. Negative 29 over positive 29 gives us negative 1. And 21 plus minus 21 here gives us 0. So this is 0. So our matrix ABCD is 1, 0, negative 1, 0. Which means, of course, that A is 1, B is 0, C is negative 1, and D is 0 if you wanted to write them out. Now let's go back here. So we have determined the values of A, B, C, and D. And now it says we must state the coordinates of Z such that Z, this point XY becomes this one. Now, I want to point out something that is happening. Notice here that 3, 5 in this point becomes 5, negative 3. And what that looks like is these two numbers have been switched around and this sign of the end one changes. Look here again, 7, 2 becomes 2, 7. They have been switched around and the sign of the end one changes. That's very familiar, and that's something that happens during rotation. So if we want to state the coordinates of Z using that, we could take that matrix that we have, and the matrix that we just found was 0, 1, negative 1, 0. So you can do that. 0, answering part 2 here, 0, 1, negative 1, 0, and you can multiply it by your xy, and that would give you this point. But since you don't have this point, we have to work it backwards. So since you notice here that 3, 5 become 5, negative 3, it would seem then that we need to switch this back. So you take 3, 5, you switch these two, and you get 5, negative 3. Switch them and change the sign of the n1. There, notice it? 7, 2 becomes 2, negative 7. Switch them. So this xy was switched, and then the sign of the n1 changed. So let's start first by writing down 5, 1. And then since the sign here was switched, let's put it back to negative. And now let's reverse them. So this would be 1, 5. Normally, a question would give you the xy and tell you to find the image under the transformation. In this case, they gave you the image and asked you to find the coordinate. All right, so here we have it. ABCD. You would take your ABCD and multiply your point, and you would get your image. And this, we are saying, this is your xy, this is your z that you would use. All right. Now, describe fully the geometric transformation M. Now, I mentioned earlier that in a rotation, especially a 270-degree rotation, 270 degrees anticlockwise, your coordinates are switched like that. 3, 5 becomes 5, -3. So you switch them around and you change the sign of the y1 when you switch them. And it's a 270 degrees anticlockwise rotation, rotation, about the origin, or a 90 degrees clockwise rotation about the origin. So either of these will describe this transformation, 270 degrees anticlockwise or 90 degrees clockwise. Remember now, to find the matrix, you simply first need to set up that matrix, set up the matrix equation, and in this case, ABCD times your points gives you your image. If this matrix was over here on this side, then you would pre-multiply it. That is, you would put B inverse first. But because this matrix is on the other side of the ABCD here, then we post-multiply both sides in order to get our result. Notice what we did here. And you can go back through the solution and look at it. Let's look at the second one now. Here we want to find the matrix of a combined transformation. The diagram not drawn to scale shows triangle ABC whose coordinates are stated. So here they are. Triangle ABC undergoes two successive transformations, V followed by W, where V is equal to 2, 0, 0, 2, and W equal -1, 0, 0, 1. And we are supposed to first state the effect of triangle of V on the triangle ABC. Without a lot of experience looking at this, you should see that these numbers will make this triangle twice as big. And that to you should sound like an enlargement. And in general, yes, for part one, answering part one, any matrix K, 0, 0, K, this is what we call an enlargement matrix, where you put the scale factor there. So whatever the scale factor is, it would go here. In this case, the scale factor is 2. So state the effect of V on the triangle ABC. The effect of V is to magnify or enlarge triangle ABC using scale factor 2. So that's what it would do to it. Now, the second part of the question. Determine the 2 by 2 matrix that represents the combined transformation of V followed by W. This is very important. V followed by W. So V is going to act on your triangle first, and then W is going to act on it. So let's take a point. Let's write down part 2 of the question. We're answering part 2 here. So let's take a point XY. So V is going to act on it first. It says V followed by W. So V first. And after V does what it does, then W is going to act on whatever is here. So V works on it first, and then W works on it after. And that tells us that we need to find the matrix WV. And it's always like that. So if you're looking at the matrix for a combined transformation and it says V followed by W, you need to find the combined transformation matrix in the opposite order. So V followed by W is not VW, but it's going to be WV. And so what we're going to do then is to take these two matrices and multiply them together. So V is 2, 0, 0, 2, 2, 0, 0, 2, and we're going to multiply by the other matrix, W, which is -1, 0, 0, 1. And once we do that, we're going to get our combined matrix transformation, WV. So we multiply row by column. row by column. Negative 1 times 2 is negative 2 plus 0. Negative 1 times 0 is 0 plus 0 again. And here 0 times 2 is 0, and 1 times 0 is 0. That gives us a 0 there. And 0 times 0 here is 0 plus 2. And that tells us that our matrix is negative 2, 0, 0, 2. So that would be the matrix for the combined transformation. So remember, V followed by W, we do not find VW, but we write it in the opposite order of WV. And this is what we find. This is the answer to part 2. And now the third part is simply to find the images. So it says determine, using your matrix in B, that's this, determine the coordinates of the image of the triangle ABC under this transformation. So let's see what this triangle does to this point. Let's take C for example. This matrix, negative 2, 0, 0, 2. Let's multiply it by C and see what it does. Now C is 2, 1. So let's multiply it by 2, 1 and see what it does. What it does to C. This is C. So negative 2 times 2, row by column. Negative 2 by times 2 gives us negative 4. And 0 times 1 is 0. And 0 times 2 is 0. Plus 2 times 1 here is 2. And so what we get is that matrix is going to make the point 2, 1, negative 4, 2. So the image is going to be negative 4, 2. So what will it do to the other images? It's going to do pretty much the same thing. It's going to double them, and the first one is going to be negative. So this is A1, A1, 2, they're going to be doubled, and the first one negative. So double this, 2 times 1 is 2, it becomes negative 2 though, and then this is 4, double them, and the first one is negative. So double, that's negative 2 and positive 2. So taking that matrix, whatever it does to one, it will do to all of them. So you do not need to multiply out all of them. You simply see the effect it has on one point and then use that same thing to copy it to the other points. So we multiply the combined transformation matrix by C, and this would be C prime, this would be A prime, and this would be B prime. Final question. Here, the matrix 1, 2, 1, 3 maps the point Q, which is 1, 2, to Q prime 5, 7. We are supposed to find the 2 by 2 matrix which maps Q prime back to Q. And this is what we call the inverse transformation. We want to find the matrix that will switch this point back to this one. To do that, what we need is to find the inverse of the matrix. So we will find the inverse of the matrix. Find the inverse of the transformation. Well, since I have it up there, let me not write it again. Let's just do it. And the matrix is this: 1, 2, 1, 3. And we need to find its inverse. To find its inverse, remember, we need to find determinant. So the determinant of this is going to be 3 times 1. Let's just call it A. 3 times 1 minus 1 times 2. And that gives us 3 take away 2, which is 1. So it comes out nice and simple. And then our inverse matrix is 1 over 1, which is nice, times this matrix that we rearrange, 3 here, 1 here, and change the sign of these two, negative 2, negative 1. And since we're multiplying by 1 over 1, everything remains the same here. So our inverse transformation is going to be, the inverse transformation is going to be 3, negative 2, negative 1, and 1. Now, let's check it to make sure that it actually does what it's supposed to do. So this matrix should take this point back to this point. So let's check it and see. 3, negative 2, negative 1, 1, and we're going to multiply it by 5, 7. and in multiplying it by 5, 7, it should take us back to 1, 2. So 3 times 2, remember we go row by column. We go, so now it's 3 times 5, that's 15, plus negative 2 times 7 is negative 14. And next row by column, 1 times 5, negative 1 times 5 is negative 5, plus 1 times 7 is 7. And doing this calculation, 15 minus 14 here gives us 1. And negative 5 plus 7 is 2. So you can see that it actually maps it back. So what we do in this kind of question where you get a matrix, this is the matrix that maps this question, this point to that image, and we want to find the matrix that maps it back. We find what we call the inverse transformation, and that simply is the inverse of whatever matrix that we get. So you find the inverse of that matrix and it will map that point, map the image back to the object. Remember that you can find more past and practice papers, which are arranged by topic, on our website at csecmathtutor.com in the past and practice paper pages. If what we do matters to you and if you have benefited, please consider subscribing and show your appreciation that way. So subscribe and share with somebody who needs to learn this information. This is important as we go through together in this time. Share with somebody who needs to learn and share your own understanding of it as well, because while you share your understanding of it and explain it to somebody, you're actually studying yourself. That's a wonderful way of studying when you share. Continue to learn and grow, and the best wishes as you continue to prepare for your exams. Thank you for watching.